Hey guys, this is Coach Lowe, and we are going to talk a little geometry today. This is section 10.2, measuring arcs and angles, or angles and arcs. All right, so hopefully you have your notebook out and you are ready to go. I'm sure you do. So let's get a circle. You can draw it about medium size would be fine. It doesn't have to be crazy big, but big enough that we can write some things on. All right, so circle P. Remember, we name circles by the center. So let's go ahead and draw an angle here with its vertex at the center, and this is called the central angle. Central angles have their vertex at the center of the circle. All right, so let's go ahead and put some letters here. This angle is equal to the degree measure of this arc. They are equal in measure. So if they tell you that this is, I don't know, let's go with 97 degrees, then this arc is 97 degrees. It's not its arc length, it's a degree measure. So 97 degrees out of how many all the way around? Right, 360 degrees. And we'll use that in just a minute. All right, so let's talk about this arc AB. Arc AB is a minor arc, and a minor arc means that the arc measures less than 180 degrees. All right, so it's the shortest arc that connects two endpoints of a circle. So when I say that, I know that you can see this arc on the back side, AB. That's a major arc. The minor arc is the shortest distance between these two. So shortest arc connecting to endpoints on a circle measures less than 180. All right, I'm going to put another point on this circle. We'll just go ahead and extend this out and make this a diameter. Put a D here. Whoops, not with the highlighter. That was crazy. Too much. All right, so let's go ahead and put a D here, and let's talk about arc A, D, B. A lot of times major arcs, major arcs will be named with 3 letters because if I just name it with 2 letters, I'm speaking about the minor arc AB. So major arc ADB, its endpoints connect, or it's an arc that connects 2 endpoints, and it's the longer one. So it's the longest arc connecting 2 endpoints that are on the circle. And it measures more than 180. Stop the video or pause the video if you need to back up and listen to another part of this, or you just need some time to write. Just go ahead and pause it. All right, so also the diameter of the circle, the arc that goes with the diameter of this circle is a semicircle, right? 180 degrees. An entire circle is 360. The semicircle, the endpoints are at the diameter. And it measures 180 degrees. All right, congruent arcs have exactly the same measure. Their central angles will also have the same measure, so that will be kind of nice to pick out. Adjacent arcs are very similar to adjacent angles, where adjacent angles, these two, would share a side. And I also know that when I add these two together, or when I know these two measures, I can add them together and I can get from AP D. I can get that angle. Now, in our case, that's 180 degrees, right? Because this is a diameter of the circle. So I can actually calculate this missing angle DPB because I know these two are a linear pair. So 180 minus 97 gives me 83 degrees, which is this angle here. And so that kind of makes it nice when you have adjacent angles. When you have 2 out of the 3 numbers, you can find the missing angle. It also helps you find the arc, doesn't it? So this is 83 degrees, and we know this semicircle is 180. All right. Arc length. Let's talk about that, and then we will work some problems. So I have the degree measure, but I don't really have the arc length yet. So when I want to find the arc length, here's what we do. We find the circumference of the circle. So going all the way around, calculate the circumference of the circle, which is 2 pi times the radius, and then we're going to multiply it. So let's say that I want the length of arc DB. The length of arc DB. How much of the circle? What fraction of the circle is arc DB? Well, it's 83 degrees out of 180 degrees. So I calculate how far around the entire circle is, its circumference, and then I just want this piece. How far do I go from D to B? So I want 83 degrees out of 360 degrees. All right, so obviously they would have to give us the radius, which they will in a minute, but once they give us the radius, we can definitely calculate the arc length. All right, let's try some problems now. All right, the diameter of O is 24 units long, which, if the diameter is 24, it makes the radius, 12. It's half of it, isn't it? Find the length of each arc. So we want arc length, which means we are going to use the little trick that we looked at just a minute ago. We're going to find the circumference of the entire circle and then multiply it by how much of the circle, the arc, what degree that arc takes up. All right, so let's go ahead and find the circumference. Circumference is 2 pi times the radius, or we could use pi times the diameter, right? So either way, the circumference is 24 pi. All right, so I'm going to go ahead and get well, let's just leave it like that. We'll stick it in our calculator in just a second. All right, so let's look at arc DE. So here's arc DE. It says DOE is 120 degrees, which makes arc DE 120 degrees out of 360, right? That's the fraction that it is, how much it is out of the entire circle. So for number 1, we will take the circumference, 24 pi, and multiply it by 120, divide it by 360. So this is the fraction. This is how much of this arc is taken up out of the entire circle. So 120 degrees out of 360 degrees. So entire circle all the way around, 24 pi. But we only want this little piece right here. So 24 pi is about 75.4. So let's say this is in inches or centimeters or whatever. It will be a length. So 75.4 all the way around. Well, how much is it just for this blue piece? Well, we'll multiply that by 120 and then subtract from 360. But I want to show you something before we do that. And you don't have to do this every time. You can just pop it on your calculator. But I want you to see something. I'm going to reduce this. 12 divided, so I marked out the zeros. And then 12 and 36 have a 12 in common. So that makes 1/3 here. So I want you to look at this. Here's what I'm finding. I want 1/3 of this circle, because what that says is this arc takes up 1/3 of the circle. All the way around is 24 pi. I just want 1/3 of the way around. All right, so 24 pi times 1/3, or we can think about that as dividing by 3, which would make this 8 pi, or about 25.1 units. So about 25.1. All right, so let's try DEA now. DEA. Well, we know we're going past 180 degrees, so this is going to be more than half of 24 pi. All right, so let's figure out what this angle is. It says DOE is 120. We know this is 90 degrees. So when I put these two together, that's 210 degrees of the circle. All right, so part 2. 24 pi is the circumference. That circumference is not going to change unless they change the radius. So all the way around the circle, 24 pi, and then 210 out of 360 degrees is the length of this arc. 120 plus 90, 210. All right, so now I'm going to take 24 pi and I'm going to multiply that by 210, or you could do 21 and then use 36 on the bottom, and then divide that by 360 if you use 210, and we should get more than half, so 43.98, or about 44 units. All right, and we know that 75 divided by 2 is 37.5, so we are good to go. That makes sense. We are more than halfway. All right, let's try one more. BC, angle COB is 45. Well, we know this arc and central angle are the same, so this is 45 degrees, but they want arc length. All right, so let's go with this arc length here. 24 pi, same circumference, multiplied by 45 out of 360. 45 degrees out of 360 degrees, that's the fraction that this arc represents out of the entire circle. So 24 pi, and we'll multiply that by 45 and then divide that by 360, and that's 3 pi, or about 9.4 units. All right, a couple more here. The diameter is 15 units long, right? So we know that this is 7.5, don't we? The radius is 7.5 if we need that. But we could just go ahead and do circumference. Circumference is pi times the diameter, so we know the circumference is 15 pi. All right, so SPT and RPT are congruent. We know those two are equal in measure. Find the length of RT if SPT is 70 degrees. Well, if these are congruent, that means their arcs are also congruent. So for number 5, I have 15 pi multiplied by number of degrees out of 360 that arc takes up. So 70 degrees divided by 360. So 15 pi multiplied by 70 divided by 360 gives me about 9.2 units. All right, so hopefully that makes sense to you. There's a couple of problems kind of along the same lines. Let's look at one more. MST. Arc MST. Arc MST is a semicircle. It's 180 degrees. So if all the way around is 360, MST is 180. The circumference is 15 pi all the way around. What would MST come out to be? Well, it would be half of that. Or divide that by 2. So 15 pi divided by 2 is about 23.6 units. All right, a couple more weird ones. Let me go ahead and grab these real quick. All right, so grab them, and they look just a little bit different here because look over here at this circle. Ooh, no numbers, right? All right, so they don't give you length of the diameter or the radius. So now we're dealing in degree measure. So it says in circle R, AC and EB are diameters. So we know 180 here with these three guys. We know 180 here. 180 here. Find each measure. Okay, so ERD, and maybe say, well, obviously it says 4x. but I think we can find the degree measure because we know these three add to be 180. So let's go ahead and do that work up front before we start working on these problems, see if we can get this figured out here. All right, so we know that the three of those angles have to add to be 180 degrees. So 4x and 15x is 19x, 19x and 7x is 26x, and then negative 3 minus 5, excuse me, positive 3 minus 5 is a negative 2, or minus 2, 26x minus 2 equals 180 degrees. All right, so we'll add 2 to both sides and then divide both sides by 26. I said add 2 and then I didn't do it, did I? Because 180 plus 2 is 182. Divide by 26, so 182 divided by 26 is 7. So x equals 7, which means now we know all of these angle measures. So 7 times 4 is 28 degrees. 7 times 15 plus 3 is 108 degrees, or 15 times 7 plus 3. And then 7 times 7 is 49 minus 5 is 44. All right, so quick check. Is 44 plus 108 plus 28 180 degrees? And yes, it is. Okay, we can also find this angle because we know that that would be 180 minus 108 minus 28, because these three together is 180 degrees. So this is also 44 degrees, which makes sense because that one's 44, this one's 44. They're also, what are those called? And they share, yeah, vertical angles. All right, so we know that. Ooh, now we can find this one. We've got every angle now, don't we? We've got all the angles. All right, so 180 minus 44 gives me this angle, the purple one. So that's 136 degrees. All right, we are now good to go. We can answer any question they throw at us. So let's see. Angle ERD. ERD, 28 degrees. All right, pause the video, see if you can do the rest of these. CRD, 108. BRC, 44. Notice we're not giving arc length, we're giving the measure. All right, so ARB, angle ARB, 136 degrees. So notice measuring the angles, not the arcs in this case. ARE, 44 degrees. And then last one, BRD, 108. And I write 180. All right, 108 plus 44 is 152. And that's the measure of BRD, this angle right here. All right, guys, kind of a long video, but lots of good stuff in it. Be ready to work when you come back to class. This is Coach Lowe, and I'm out.